Alrighty, what we're gonna do is I'm gonna go over your practice test that I gave you on Friday. So some of you might not have done so well. So I want to make sure that I can go over it with you, so you know what you did wrong for Monday, and maybe this will help. So it'll be very similar tests. So after this, I'm gonna send you another practice test so you can try again. All right, let's get working. That's me. Hopefully I get 100. All right, let's start this game. Ooh, countdown. Exciting. Okay. All right. A controlled experiment, the variable that is changed to test the hypothesis. All right. So I'm going to use some visual aid here. So independent variable is probably the most important word you're going to need. Okay. Just think independent variable is what I change. I change it. I for independent. I change it before the experiment. Should be the only thing different. Okay. So we'll talk a lot about independent variables. So I don't go over it too much now. But just look for the one thing that's changed that you want to look for the effect. Okay, so for the question, what is change to the hypothesis? If you said, I want to see, or I predict that if I study more for this test, I will get better test scores. So what am I changing? The amount of time studying. That is your independent variable. Okay. There you go. Independent variable. Yeah. Jazzy. The measurable factor. Okay. This is one you just have to memorize. Like just memorize it. If just take the time, make sure you know that measuring is dependent. Okay. There's not really a great way to remember that. Okay. Just force it in your brain. What you measure is the dependent variable. Okay. So how much is it going to grow? Well, it depends. Okay. It depends on what you do to it. So measuring, just gotta have those down. If you mix them up, it's going to be tough. Which of these contains steps in the right order? Okay, so scientific method. Okay, think about it. You notice something. Okay. Ooh, I noticed that when I put these plants near that window, they tend to grow more. That's a question. Okay, so then you predict. I think that if I put it near this window, it's going to grow more. Okay, so you always want to observe before you ask a question. Okay, form a hypothesis, plan an investigation, draw conclusions, report and share results. Okay. Ooh, I noticed this. Okay, I have an idea. I want to test it. Okay, here are my results. I think this. I should tell somebody. Boom. Not too fancy. Some researchers are developing new fertilizer. You're getting a lot of these type of questions. Okay, so just look for a couple things. Okay, no matter what it is, even if you have no idea what it's talking about, so some astrophysics, look for a couple things in every one. A new fertilizer, it's always plants, right? Designed to improve the growth of plants in hot, dry climates. Okay. The fertilizer was applied to 100 desert plants in a greenhouse. Okay. This is very similar to the Mythbusters we watched. The average daytime temperature in the greenhouse was at 90 degrees and humidity levels were low. Okay, what is best for the researchers to do? Okay. All right. So they want to see if the fertilizer improves new growth. Okay. So how are we going to determine if fertilizer makes it grow more? Well, we need to have some plants growing in these conditions with fertilizer and some without. Or else, how are we going to know that fertilizer helps them grow more? Okay. So let's look at some answers here. So let's go good to go through them all. Okay. All right. Compare plants that receive fertilizer to ones that didn't. That seems good. All right. This is Alrighty, don't ever pick that one. Change the conditions in the greenhouse and restart the fertilizer. No, we are just testing the fertilizer. We're not testing the different conditions. Test the fertilizer on plants that are adapted to. Okay, so there's some bad answers here. Metal things in the way. I'm gonna move that. Oh, I just got rid of myself. It's okay. Yeah, so it's this one. Okay, you always want to have one thing that's getting the thing you're testing and one thing that's not. There you go. Experiments performed on plants to see how different liquids affect plant growth. Always plants, right? Each plant and the amount is experiment is given a different type of liquid, water, apple juice, or milk. Interesting. Each plant has the same amount of soil, sunlight, and listens to the same music. Right. So these are constants. Okay. So the independent variable is the one thing that isn't constant. Okay, so going back to my little adapt here, it's the one thing that changed. Like the type of liquid. Actually, this is very similar to the one we have here. Okay, so you're changing the liquid type. So what do I change? I change the type of liquid. Okay, these are constants, controlled variables, you could say. They should be the same for everyone. So the only difference, the type of liquid. Independent variable, I change the type. Aye, aye. Capone. If I study for my scientific method test, yes, then I will have a better test score. All right. What is the dependent variable? Okay. So just remember, dependent variable is what we're measuring. So what am I going to measure to determine if my hypothesis is right? What's going to tell me that I am right or wrong about studying and getting a better test score? It is the test score. I measure the test score to see if it's true. You don't measure how much you study to see if it worked or not. Okay. You need the test score. Okay. The independent variable would be the amount of studying. Test score is dependent variable. Know those. Okay. If you don't know those going into Monday, you're going to miss a lot of questions. You can see that. Hammer that down. Hammer it down. What this describes the purpose of a controlled experiment. Okay. So a controlled experiment is one where you keep everything the same except for one thing. So like we got the same amount of students over here, right? Hey, we got even 2 boys and 2 girls. Great. Same kind of desks. Everything looks the same. The only thing different is this noise here. Okay. So the question is, will student test scores be affected by distracting sounds? The only way to know if the distracting sounds were the cause of different test scores in the control and the experiment group is keep everything the same except for that noise. Okay. So the point is, let me go back over here. The point, I'm going to close that out. The point is you want to make sure that your results are because of only the one difference and nothing else. Okay. Let's see. To prevent a dangerous condition resulting from reaction. Interesting. Some bad answers in here. To examine whether one variable causes a change in another. To prevent an undesired change in a variable. And none of these other answers even make sense. So this one should have been one of those where you eliminate bad choices. You would have been left with just this. To examine one variable causes a change in another. Yep, I'm only changing the noise in that example so I can see if that changes the test score. Nothing else. All right? That's an important one. Kind of all these relate to that concept, to be honest. All right, 3 baseball players investigate to see who can throw a baseball the farthest. They mark off an area on the playground for their investigation. Which should they keep constant? Okay. All right, so let's see what we got. I'm going to use a little thingamajig here. All right, so let's see. Constant means what should they keep the same? They're investigating how far they can throw the baseball. Okay, they mark off on the player in their investigation. You just want to, this is kind of a weird one. It's not really totally a scientific question. So what should they keep constant? Height of the players, color of the balls thrown, order of the players throw, spot from which the players throw. So you're kind of analyzing which is the most important to keep the same, like which will prevent you, okay, if it's different from seeing actually who can throw the baseball. Color, no. Height of the players, hey, all right, you're not really investigating height. It's a spot of the players throw. I mean, if you think about it, if that's different, it's gonna be hard to measure, like how, if you just measure the distance. So players throw. It's not a great question, but I probably won't put one like that on the test, but something a little better maybe. Company wants to sell more sports drinks. They decide to add more sugar. Right, always more sugar. It's my favorite independent variable is sugar. For group A, they give them Gatorade, add a teaspoon. I'm going to do a little highlighting here. All right, for group A, they give them Gatorade. Okay, so group A gets Gatorade, an added teaspoon of sugar. Okay, so an added teaspoon of sugar. So one group gets a little bit of extra sugar. For group B, they get plain Gatorade, no sugar. Okay, without adding sugar. Okay, so that's our difference. Group A has teaspoon of sugar. Okay, group B has no sugar. What is the control group? Well, we obviously need to know what a control group is. So let's go back to this little picture here. Okay, so in this test, they're testing to see which student will be to distracting noise. Okay, that's what's different. Control group, no distracting noise. Experimental group, distracting noise. So the control group is always one that doesn't get the independent variable that you're testing. Okay, so which one is not getting what they're testing for, which is more sugar? That is going to be group B. All right, group B. Bam. How can you create a fair test? Very similar question on it before. It's 2 because it's important. Remember, fair test is everything the same except for one thing. Okay, if we change, let's go to my Gizmo. I have my Gizmo open. There we go. So, like, if we want to see how changing water affects how these plants grow, okay, we can't give this one more light, all right, than the other ones, all right, because how are we going to know if it's the water, okay, that causes it to grow more or the light? You don't know. You have to guess. You never want anyone to be able to say, well, I don't agree with your test because your results, because how do you know it wasn't this causing the difference? You don't. But everything needs to be the same. And it's the most important concept of science is narrowing down all the outside stuff so you can just look at one thing. So there's no opinions. Okay. We don't want opinions in science. We just want to look at data and say, yes, that is the reason why these students did better. Okay? So by changing one factor and keeping all the conditions constant, that sounds pretty good. Some variables, no, you want to change one. Yeah, repeating is good, but it's not has nothing to do with being a fair test. Okay. All right. Ryan wants to test which cleats enable him to run the fastest. Which question is the best scientific question? So you'll have to do a few with questions. Is a good scientific question has variables. Okay. You always want to put your two variables in the question. All right. Something that you're testing and something that you're measuring. The biggest thing is if you can't measure it, it's not a good question. Okay. So let's see. Which cleats will help me run faster? All right. Okay. Which brand of cleats will help Ryan to run the fastest time in the 100 meters? So this one's not bad. So like I wouldn't X this one out of right. So I put like a little check mark. Okay. It has a variable and it has something you can measure, but it says best. Which brand of cleats? Okay. So we got specifics, right? Which brand of cleats will run fastest time in 100 meters? We have a specific thing we're measuring. Okay. Will cleats are okay? That was a typo there, so you should probably get rid of that one right away. Which brand of cleats help Ryan run better? Okay, little thing in here. Never pick something with better. Okay, better is not a scientific word. You need to define what better is. In this case, it's the fastest time in the 100 meters. This one is more specific. So these are both, if this one wasn't here, then this one would be the best, but it is. This one is more specific and more measurable. We're going with that guy. Oh yeah, boom shakalaka. And yep. Okay, what was the dependent variable in this test? All right, so anytime you get one of these on the quizzes, all right, make sure you click that to expand. Oh, it's kind of hard to see. So dependent variable, that is what we're measuring. Okay, this is right off your plant gizmos. Let's take a look, see. What are we measuring here? Okay, all right, so another clue too, you're always measuring what's on this axis. We'll do more of this when we get back from break. Okay, but you're always measuring what goes up and down. Okay, so what is on the up and down? It's mass. Okay, they're measuring mass. Okay, so these are all different variables. We're measuring the mass. Okay, so we can go back and look for mass. Okay. Soil type, no, we're measuring the plant mass. Some of you might have got that one wrong on the test because the one version I had two plant mass options. So if you put plant mass and it said you got it wrong, you actually were right. So good job. What was the independent variable? Okay, you can see how these words are important. All right, so we're looking for refresher. All right, what is different? The one thing I'm going to change. All right, so let's see. Let's find what we are changing here. All right, let's see. Water is the same, 30 milliliters. So that is not your independent variable. They're all beans. So that is not your independent variable. They all have the regular soil. Okay, so the difference is the amount of light, 0, 1, and 2 bulbs. So like right here, all right, we got 0 bulbs, 1 bulb, and 2 bulbs. That is our differentio. Erase. Oh, isn't there a clear button? Should be. Wipe screen clear. Oh yeah, there we go. All right, so let's go back. And monoblank. Excellent. All righty. Ooh, picture. So once I do these pictures like this, it's much easier to get me questions in the quizzes. So that's why I do the pictures. All right, the hypothesis. All right, the addition of a fertilizer to, you guys will be plant experts here, of a fertilizer of soil will increase plant growth. Okay, that is the prediction. Okay, so how would you set that up to test your prediction? All right, so let's take a look at each one. No fertilizer, no fertilizer. Okay, well, we're testing to see if fertilizer helps grow. So this one has no fertilizer, so that's not a good one. Okay, this one's got fertilizer. Okay, both, then both. Okay, how are you going to know if fertilizer helps plants grow if they both have fertilizer? Okay, in this one, the only difference is water. So this would really test to see if water works. So we're getting rid of that one. Boom shakalaka. All righty, let's see. Let's get rid of the other bad one first. Okay, this one has, okay, fertilizer, no fertilizer. Cool. But it also has water and no water. This is bad because if you get your results and the fertilizer group grows bigger, You won't be able to determine if it grow bigger because of the water or the fertilizer. There's two differences. Get rid of that guy. All right. I'm going to change my color. Green, we like green for good. Alrighty. This one, fertilizer, no fertilizer. Okay, so it's got the requirement. Now, is everything else the same? Yes, water and water. There's one difference. We're going with that guy. All right. Excelente. And back to my pointer. It's going to be C. All right. So look, on the test, you're going to get questions just like that, just with different combinations. All right, here's an IXL question. So I told you to practice your IXL. And if you need to work on your variables, then there's like tons of practice there. So go do it. There will be questions on the test from IXL. I want to make sure people who did it, okay, are getting rewarded with that practice. Okay, so let's see here. The passage below describes an experiment. Read the passage. This is probably why you don't like IXL, if you got to do a lot of reading, right? Read the passage and think about the variables that are described. Okay, so we want to find always, when you're doing IXL, look for right away what you're looking for. So it's looking for a dependent variable. So remember, dependent variable is what we're measuring. Remember, if you miss it in IXL, then read the answer. Okay, it'll tell you like what you did wrong and remind you. Okay, so what are we measuring? Let's see. All right, playing where the apple slices are exposed to air. Okay, they turn brown. Okay, there's the observation. Justin Derrick cooking. Okay. All right, bottom part is what we want here. Justin cut an apple into 10 slices. He put 5 of the slices into a bowl and poured 2 tablespoons of lemon juice over them. Okay, so that's what he sets up. Now, what are we going to look at? He puts the other 5 slices to another bowl and did not add any lemon juice. So we have right away an independent variable is the lemon juice. With lemon juice, without. That's what we changed, but it's asking for dependent. So we want what we're measuring. Okay, after 1 hour, Justin counted the number of apple slices in each bowl that had turned brown. Okay, so we are measuring how many turned brown. So let's go find that. Hopefully it's there. All right, the number of apple slices that turned brown. Boom. This one over here is the independent. So easy to mix up, right? All right, we are all done. Not too crazy, right? There's really like 3 concepts. Okay, identifying your independent variable. Okay, which one are you measuring and which one are you changing? Making sure that everything is the same except for one thing, which is your control group, and being able to identify and write a good question. That's essentially what you're being tested on. So it's not a lot. Just practice those 3 things. Okay, don't worry about anything else really, except the things that I just went over, because that is what I'm putting on your test on Monday, and that's all we care about right now. So, alrighty, where is my thingy? I'm stopping this recording, and so I'm gonna post this with another practice test. Okay, do the practice test. I think I'm gonna add something else to that, and hopefully this helps. And good luck.